This is how to draw Lewis structures. We're going to use these steps. We're going to add up the total valence found on the periodic table. We're going to put the least electronegative element in the center and put the bonded atoms around it. Then we're going to take the total valence, which is from number 1, subtract the number of surrounding atoms times 8, and that's going to tell us how many electrons would go around the central atom. Once we know that, we will make sure there's an octet around the central atom with bonds if necessary, and then we will make sure that each of the surrounding atoms have octets. So let's get started. First step is to add up the valence for all of my elements. So here is argon, and argon has 8 valence electrons. And then here is fluorine. Fluorine has 7 valence electrons. So we'll say 8 plus 7 times 4 is equal to 36 total electrons that I can have in my drawing. I'm going to put the least electronegative element in the center, and I'm going to draw a skeleton structure. So basically argon goes in the middle and it's surrounded by 4 fluorine atoms. Next, I'm going to take the total number of surrounding atoms, which is 1, 2, 3, 4, and I'm going to multiply that times 8, and that gives me 32 electrons. I'm going to subtract these two, and that tells me how many electrons go on my center atom. I need a total of 4, and they should go on as pairs. So I have one pair here, and I'll put the other pair on the other side, and since they are pairs on the central atom, we're going to put a bubble around them. I like to call it an alien head, because this lone pair is exerting a force on its neighboring atoms, and so I like to show it with kind of a little bubble around them. Now, we need to make sure that all of our atoms have octets. So far, argon has 2, 4, 6, 8, 10, 12. It has more than an octet, so no need to add any more electrons to argon. Each fluorine so far has 2 in the dashed line, so we'll do 4, 6, 8. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, and 8. So now all of our atoms have octets around them. And finally, I should check my total, and my total should equal the original 36 that I calculated. So if we count the total, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So I do have a total of 36 electrons in my drawing, and every single element has 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12. They all have at least 8 electrons around them. To find the electron geometry, you're going to be asked to find 2 things. One is the electron geometry, and that's based on the total number of things around the center. I have a total of 1, 2, 3, 4 fluorines, 5, 6, right? So I'll mark my individual things that I'm counting. I have 1, 2, 3, 4, 5, 6. Because there are 6 things surrounding the central atom, that means that my electron geometry has 6 things around the center. It is called octahedral. So this is called octahedral. The molecular geometry is going to be more specific. It's going to be based on the fact that there are 2 lone pairs around the center. So now that I know it's octahedral, I'm just going to go find the shape that has 2 lone pairs on the center, and that's going to be this one right here, and that's called square planar. See how it has 2 alien heads around the center. So this is called square planar. There are many different charts like this that you can find online to help you out. Next is pH 3. We're going to go add up the total number of valence. So phosphorus has 5 valence and hydrogen has 1 valence. So it's going to go 5 plus 1 times 3 equals 8 electrons. And so now I'm going to draw the skeleton structure. You're going to put phosphorus in the center, and you're going to surround it by 3 hydrogens. 1, 2, 3 hydrogens. Now, for the record, hydrogen should never have more than 2 electrons maximum. So 2 electrons max for hydrogen. So it's never going to have anything more than 1 bond to hydrogen. Never put any pairs of dots around hydrogen because it only needs 2 electrons maximum. Now I'm going to figure out if I need any electrons on the phosphorus. So I have 1, 2, 3 hydrogens times, and this will be an exception, 2 electrons for each of them, and that's going to be a total of 6 electrons. And when I subtract these two numbers, I get 2 electrons that are going to go on my central atom. So now I'm just going to put 1, 2 on phosphorus, and because it's a lone pair of electrons on the central atom, it'll get an alien head around it. Now we want to make sure everything has an octet. We have 2, 4, 6, 8. Phosphorus is good. And then each hydrogen should just have a duet, or 2 electrons. 2, 2, 2. So now I can count my total. I have 2, 4, 6, 8, and that matches my original 8 electrons that I have. Now I can look up the electron geometry and the molecular geometry. So I have a total surrounding 1, 2, 3, 4 things around the center. So when I look at my electron geometry, I have 4 things around the center. That's called tetrahedral. And because this one has 1 alien head on it, its molecular geometry is called trigonal pyramidal. So this is called tetrahedral, and this is called trigonal pyramidal. And there's your answer for pH 3. Add our valence, carbon and oxygen. Carbon has 4 valence, oxygen has 6 valence. It's going to go 4 plus 6 times that 3, and because that says -2, we're going to add 2 more electrons to our total, and so this gives me a total of 24 electrons. So I'm going to draw my skeleton structure. I'm going to put carbon in the center, 1, 2, 3, and I'm going to surround it by the 3 oxygens that are in this molecule. Now let's figure out how many electrons go on the carbon. So it's going to be 1, 2, 3 oxygen atoms times, they should get octets, so times 8 equals 24 electrons. If I subtract 24 minus this 24, I need 0 electrons on this carbon. So we don't add any dots to this carbon. Now everything needs an octet, so when I check the carbon, it has 2, 4, 6. It needs another bond, and since we're not putting dots, we have to put bonds now. So since it needs another bond, I'm going to add another bond between this carbon and this oxygen. It doesn't matter where you put the second bond because all 3 of these are oxygens, so any of these 3 spots would work. Now make sure each element on the side has an octet. This oxygen has 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Now everything should have an octet. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and the carbon has 2, 4, 6, 8. Everything has octets. Now, do I have a total of 24 electrons in my drawing? We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We do have 24 electrons in the entire drawing. Now I'm going to go look up the electron geometry and the molecular geometry. So for my electron geometry, I have 1, 2, 3 things surrounding the central atom. Notice it doesn't matter that this is a double bond. I'm just counting the oxygens. So because I have 1, 2, 3 things surrounding the central atom, that means that I have 3 electron densities. That's going to be called trigonal planar. So this is called trigonal planar. And there are no lone pairs on the center atom. So when I look here, it's going to be this one, trigonal planar again, because we don't have that lone pair on the center. So fun fact, anytime there are no lone pairs on the center, then both of these names are always going to be the same as each other. All right, one more. Let's add the valence for iodine. Here is iodine, and it has 7 valence electrons. So we're going to do 7 times 3. That plus 1 means minus 1, and that's going to equal 20 electrons total. That should go in my drawing. Obviously, we have 3 eyes, so it's just going to be an eye in the middle with 2 eyes on either side of it. So it's going to be like that. Now, I want to find out how many pairs of dots are going to go on my central atom. So I have 1, 2 bonded atoms times, they're going to each get an octet. So 2 times 8 equals 16 electrons, and when I subtract these two, that means that I need 4 electrons on this central atom. So I'm going to have 1, 2, 3, 4. Always want to add them in pairs. And then I'm going to put an alien head around this one and an alien head around this one. Now, everything should have an octet. Let's check. 2, 4, 6, 8. 2, 4, 6, 8, 2, 4, 6, 8. Now everything has an octet. Does my total add up to equal 20 electrons? Let's check. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. My total does equal 20. Therefore, this is the correct Lewis structure. What are the electron domain and molecular geometries? Well, when I count around this central atom, I have 1, 2, 3, 4 surrounding electron densities. And so 4 on the list is going to be this, tetrahedral. And I have 2 lone pairs, or 2 alien heads, so that means the molecular geometry is going to be called bent. So this is tetrahedral, and this is bent.